In this lecture, we will learn about computer storage. First, let's take a look at the units of storage, the different units that measure how much information can be stored on a computer. 1 bit is equal to 1/8 of a character. 1 byte is equal to 1 character of data. 1 kilobyte is equal to 1,024 characters. 1 megabyte is equal to 1,048,576 characters. 1 gigabyte is equal to more than 1 billion characters. 1 terabyte is equal to more than 1 trillion characters. 1 petabyte is equal to more than 1 quadrillion characters. 1 exabyte is about 1 quintillion characters. 1 zettabyte is about 1 sextillion characters. Everything eventually compiles down to ones and zeros, or binary code for the computer to process. Binary code is the language that the computer understands. 8 bits come together to form 1 byte. 1 byte can represent 1 character of text. A kilobyte is about half a page of text, and used to be a common unit of measure for the storage capacity of old computers. A megabyte is about 500 pages of text, and is the memory capacity for some microcomputers. A gigabyte is one of the more common forms of memory today. Many modern phones have several gigabytes of storage. A terabyte is a very large storage amount, and is common for high-capacity disk storage. For example, some external hard drives have a storage capacity expressed in terabytes. A petabyte is an extremely large unit of storage. In today's world, databases commonly have a storage capacity of petabytes. An exabyte is an absurdly large storage capacity. To give you an idea of just how large an exabyte is, all of the printed material in the world represents about 5 exabytes. There are 2 main types of computer storage: primary storage and secondary storage. Primary storage is temporary storage. It is used to hold data before it is processed. Secondary storage is permanent storage that can store data or information. Registers are the fastest and most expensive type of memory. They hold data that the CPU is currently processing. Primary storage refers to storage that only holds data temporarily. One form of primary storage is the cache. The cache can be accessed quicker than regular memory and is useful for retrieving data or information that was recently accessed. Data and instructions that are likely to be used again are stored in the cache, rather than being returned to the RAM, so that they can be accessed faster. Locality refers to information that was previously used being used again, and relates to caching. There are 2 main forms of locality in computing: temporary locality and spatial locality. Temporary locality means that information previously used will likely be used again soon. Spatial locality means that instructions closely following the current instruction will likely be used again soon. Another form of primary storage is the RAM, or random access memory. There are many types of RAM depending on the chipset that you buy. RAM is also referred to as the main memory of the computer. The RAM provides quick read and write access to memory. If the computer needs to quickly fetch something from memory, it uses RAM. If the computer needs to quickly save something to memory, it uses the RAM. Temporary storage areas are volatile, meaning that the memory is cleared out when you turn off the computer. They need to have a steady power supply going to them in order to retain the memory. Both the cache and RAM are temporary storage areas on the computer. In contrast to temporary storage, secondary storage is permanent storage. Examples of secondary storage are hard drives and flash drives. Other names for secondary storage are auxiliary storage and external storage. Secondary storage does not get erased as soon as the power goes off. This is because secondary storage is accessed from the computer externally. And there you have it, an overview of computer storage. In the next lecture, we will learn about communications.